In Morocco, water control is of vital importance because of the harsh climatic and hydrological context. The rainfall quantities vary from one region to another. They are dominated by large fluctuations in space and time. The mountainous areas, Rif and Atlas ranges, receive more rainfall, more than 800 millimeters, than the southern and eastern plains and plateaus, less than 200 millimeters. The northwestern part of Morocco, representing 7% of the area, receives 50% of the rainwater in the country. In terms of time, the strong variation from one year to another and alternating sequences of wet years and severe drought, sometimes lasting several years, are an important feature of the Moroccan climate and hydrological regime. The properties of surface water supplies in Morocco since 1945 show the following. A relatively wet period from 1945 to 1980 would average surface water inflows of 20 billion cubic meters per year, and a dry spell since 1980 with an average inflow of 15 billion cubic meters per year. The phenomenon of floods is not recent in Morocco. Vast plains were most often exposed to floods that last for weeks. And this is the case, for example, of the Gharb Plain. Major floods have been solved thanks to the dam policy that was launched by the late King Hassan II. Dams have played a prominent part in protecting cities and plains from flooding. This is the case of Idris I and Al-Wahda dams, which protects the Gharb Plain, El-Makhazin Dam for the Lukos Plain, El-Khattabi Dam for the Nectar Plain, and Hassan al-Dakhil for the region of Tafilalt. In recent decades, the frequency of such extreme events began to be felt more strongly, causing significant damage to both infrastructure and the population. This was the case of Urika in August 1995, El Hajab in 1997, Muhammadiyah in 2002, and Titwan in 2000. This map highlights the scale of flooding in the eastern areas, but also the high Sibu and Wadi Ziz, of which the parched soils contribute to further water runoff. 300-year flood were observed during the same year. During the period of 2009-2010, the floods have mainly affected western areas. A year later, the country has experienced severe flooding. Heavy flooding from the river Werga were partially retained by Al-Wahda Dam. During the following year, the eastern part of the country was spared. But all the rivers of the western regions have experienced unusually high flow rates, sometimes resulting in floods that were centenary in scope. In the pre-Rif area and the Gharb Plain, the 2009 and 2010 period will remain marked in the hydrological history of the Sibu Basin as being an exceptionally wet year, with rainfalls that reached 3,000 millimeters in the Rif and ranged between 700 and 1,000 millimeters in the other sub-basins. It was also the year when there was overflows water in all dams Sibu, including, for the first time, dams and Sidi Shahd Asfalu. Another peculiarity of this year was the concomitance of all the basin's wadis flooding. Thus, from 11 December 2009 to 12 January 2010, The Al Wahda Dam received 4 successive floods with a peak flow exceeding 3,500 cubic meters per second with a total volume of 2.4 billion cubic meters. On 13 January 2010, other Cebu tributaries experienced heavy flooding. 480 cubic meters per second in Erdat, 390 cubic meters per second in Wadi Bet, 1,300 cubic meters per second in Inawen. Flows have exceeded the maximum capacity of Wadi Cebu, 800 cubic meters per second, causing overspills in the Gharb Plain. During February, the succession of rainfall events, combined with saturated soils, generated intense water flows in the various Cebu tributaries. With 3,800 cubic meters per second in Erdat, the inflow to the plain amounted to 2,000 cubic meters per second, leading the overflows. The Gharb Plain is known for hosting 25 overflow points, taking the form of gaps along the wadis of Cebu, Bet and Rdam. These overflow points come into action when the maximum conveyance of these wadis is reached. Upstream from the center of Bilqsiri, there are 9 overflow points and 4 other points downstream. Besides, there are 8 points on Bet River and 4 more on Rdam River. In 2010, an extreme flood occurred in the Werra Basin with a maximum flow of 7,000 cubic meters per second. In parallel, a simultaneous flood affected Cebu River, registering a peak flow of 1,700 cubic meters per second at Azib Sultan. The flow at the entrance of the Gharb Plain was assessed at 6,500 cubic meters per second, while the flooded areas in the plain amounted to 135,000 hectares. Without Al Wahda Dam, which has played an important role in storing the flood basin Werra, the maximum rate would have reached 12,000 cubic meters per second. These high floods have never been seen in the history of hydrological measurements in the basin. Human casualties were limited thanks to steady vigilance and the support of civil protection, the Royal Gendarmerie, and the Mohammed VI Foundation. Once again, the exceptional hydrological events have underscored the large volumes of water inflows that are lost at sea and beyond the southeastern borders, amounting to 35 billion cubic meters, including 22 billion cubic meters from dams and 15 billion cubic meters from intermediate basins. Dams have played a role of paramount importance in protecting downstream areas, with a flood routing rate ranging between 50% and up to 100%, making it thus possible to minimize damages, especially in the Gharb Plain, due to Al Wahda Dam, which managed to eliminate 10 successive floods during 2009 and 2010. Protect the Buragrag Valley by raising the height of the Sidi Mohammed bin Abdullah Dam, and protect the city of Mohammedia and its industrial zone through the dams of Tamsna and Al-Haimer, and also thanks to the protection works carried out downstream. In the area of dam management, the Water Department has implemented a proactive program for creating hollow at the various dams of Morocco in preparation for the winter season. Monitoring the water situation and managing dams in particular are based on forecasts of the National Weather Service and on coordination with the local authorities and the various relevant departments. Based on weather reports forecasting, data analysis, and simulations of flood forecasting upstream dams and overflow points. This information is coordinated and concerted at the level of central and local vigilance committees between the Ministry of Interior and the ministry concerned to take the necessary measures during and after floods. Management guidelines are taken into account by the water basin agencies for flood control. The Department of Water conducted a flood control study which made an inventory of approximately 400 flood-prone sites. These sites were then subject to consultations between the water basin agencies and the various relevant departments. The total cost for protecting these 400 sites totaled 25 billion dirham. In partnership with the Ministry of the Interior, the Department of Water has embarked since 2003 on implementing the findings of the flood control study. Thus, the construction of protection works such as small dams and the development of waterways were achieved in about 100 of those flood-prone sites. These protection works focused on the most vulnerable areas, including the protection of cities such as Mohammedia, Barshid, Stat, Qasr al-Kbir, Sidi Qasim, Ben Hamad, Beni Millal, Wadzim, Bujad, and Shishawa, in addition to the Mohammed V Airport. Experience at the national and international scale shows that the adverse effects of flooding can be alleviated if preventive measures are taken in a coordinated and effective way by all the agencies in charge of reducing flood risks, such as civil defense, local authorities, public and semi-public administrations, the media, NGOs, etc. Furthermore, early warning systems are a key factor in flood risk prevention. The National Directorate of Meteorology plays an important and decisive role in implementing this policy and contributes to saving lives and reducing economic losses. It ensures continuous monitoring of the atmosphere, develops reliable and quality forecasts of extreme weather events such as heavy rainfall and severe thunderstorms, in addition to rapid and effective dissemination of weather alerts and warning bulletins. Improving warning systems depends heavily on the quality and density of observations and remote sensing networks, the reliability of telecommunication networks, the strength of computational resources, the scientific progress achieved in atmospheric modeling of local phenomena, continuous staff training, international cooperation, and public awareness of the risk culture. Responding to the problem of flooding is not only an issue of specialists but concerns everyone. Indeed, acting proactively makes it possible to prevent disasters caused by floods. In developing urban planning documents, enhancing construction techniques, and also making elected representatives more responsible when granting building permits, everyone can and must play a role in observing the regulations in force and raising awareness of flooding risks. Moreover, the achievement of adequate infrastructure in urban areas, such as for monitoring the development of the water system, also plays a major protective role. Similarly, the use of absorbent materials on roads and the construction of stormwater drains, to name but these two items, contribute greatly to ensuring the safety of the population.